Well, let's talk about Physical Science PACE 1111. This is the new 4th edition. And we're going to look at page 34 and question number 11. We're using the gas law that tells us that P1 times V1, pressure times volume, will be equal to the pressure after a change times the volume after the change. So pressure times volume will be equal to pressure times volume. All right, it's proportional to each other. Now in this story problem here on number 11, it says a certain amount of air, and they tell us that it's V1, at a pressure of, and they give us the 101.3 kilopascals, and I'm looking at the problems on this page. It looks like they all are in kilopascals. So that's helpful. We can have pressure in other units, but they're at least trying to be consistent with this. Sometimes it can be in atmospheres and millimeters of mercury and all kinds of things. I do notice on this page that they have different numbers of, or different units for volume, sometimes cubic centimeters, sometimes liters, and as long as we stay consistent, which it looks like they do within each problem, we shouldn't have to do any conversions. Okay, so that's encouraging, yay. So we're going to compress some air under a high pressure, 12,800 kilopascals, to fill a scuba tank. And the scuba tank holds 18 liters. And we want to figure out how many liters of air at normal pressure here had to be forced into that tank. All right. So I'm going to bring up a pen here. So the first thing we want to do, since we're solving actually for the initial amount of volume, that's what we don't know. All right, so we can put a question mark there. We know the initial pressure, we know the second pressure, we know the second volume. Since I'm solving for V1, I need to divide by P1 so that will cancel. Okay, so now I have a formula. And we can take the P2 and put that down, 12,800. Multiply that times the second volume, 18 liters, and then divide by the initial pressure of 101.3. And I'm not going to do the math for you. You can do that, but then notice in the directions it says, make sure you follow the significant figures rule. So let's think about how many significant figures in each of these measurements. Well, this first pressure has 4. The second volume has 3. And actually, the second pressure, even though there are 5 digits, these 2 digits are not significant. Okay, they're important as far as place value, but we would say that it has 3 significant figures, okay? Since we're doing multiplying and dividing, then we round our final answer to have the least number of significant figures that any of these measurements have. So it looks like we are going to end up with 3 significant figures in your final answer, all right? I want you to go ahead and finish that problem, and then when you take it up to the score key, you can grade it. And if you have the right number but you forgot the number of significant figures, at least you'll know you did the math part right, and then just review the rule, count, find the digits, and go back and fix any that you got wrong in this section.